Welcome back to this course on stereochemistry. I'm very happy to meet you all once again through this course. I hope all of you are safe and fine. So far, we have been discussing about the fundamental aspects of stereochemistry, and we have understood that a molecule is said to be chiral when it has an asymmetric carbon. Stereoisomers are classified into geometrical isomers and optical isomers, and we have seen those things in the earlier class. Today we will move on to the types of stereoisomerism, followed by these conditions of symmetry, that is symmetry elements in a molecule and symmetry operations, and how to define a molecule as asymmetric. And we will also try to understand how to define the chirality in a molecule. To start with, let us try to understand the different types of stereoisomerism. When we say stereoisomers differ in the arrangement of atoms or groups in a three-dimensional space. And the best example is an enantiomer and a diastereomer. Now, if we try to classify stereoisomerism, it can be classified into configurational isomerism and conformational isomerism. What is configurational isomerism? A configurational isomerism arises due to the difference in the position of atoms or groups in a three-dimensional space, and it can happen only by breaking a bond. A configurational isomerism can arise, or configurational isomers can be formed only by breaking of bonds, whereas conformational isomerism arises because of the rotation of carbon-carbon single bond. We have seen this conformational isomerism in our earlier classes, where we understood how different conformers can be formed for ethane, butane, etc. So we have seen about the eclipsed conformation, staggered conformation. Okay, so these are all arises because of the rotation of carbon-carbon single bond. And this configurational isomerism can be further classified into enantiomers and diastereomers. We know what is an enantiomer. An enantiomer is a pair of stereoisomers which are non-superimposable mirror image of each other. So enantiomers are exactly mirror images, but they are non-superimposable, and of course they will have a chiral carbon. And on the other hand, if we say a diastereomer is a pair of isomers, stereoisomers, which are not mirror image of each other. Okay, so they are not mirror. If you draw a mirror plane here, these two are not mirror image of each other. Okay, so a diastereomer are stereoisomers which are not mirror image of each other, and they are also classified as cis and trans isomer. So we can see here we have a cis 2-butene and a trans 2-butene. So they form a pair of diastereomer, and they also come under the class geometrical isomer. On the other hand, if your molecule contains more than one chiral carbon, okay, so this molecule has two chiral carbon. So if a molecule has more than one chiral carbon, then that molecule has a possibility to exist as a pair of diastereoisomer. So here these two molecules are diastereomers because they are not mirror image of each other. Therefore, diastereoisomerism or diastereomerism exists in cis-trans isomerism as well as in chiral molecules. And as far as our conformational isomerism is concerned, you can see we have a staggered conformation. Okay, so a staggered conformation of butane and also a skew conformation of butane. So conformational isomerism arises because of the rotation of carbon-carbon single bond, whereas configurational isomerism arises because of the breaking and formation of new bonds. Coming back to configurational isomerism, the stereoisomers which are non-superimposable and non-interconvertible by rotation around a single bond are called configurational isomers, and the phenomenon is called configurational isomerism. The best example is an enantiomer. The two isomers are non-superimposable mirror image of each other are called enantiomers, and if the two isomers are not mirror image of each other, they are called as diastereomer, and it also includes geometrical isomerism. On the other hand, conformational isomerism arises in molecules and which has the capability of rotating across the carbon-carbon single bond, and the stereoisomers which are non-superimposable but interconvertible by rotation about single bonds are known as conformational isomers or conformers, and the phenomenon is called conformational isomerism.